Hi everyone, it's Scott from Maths Logos. In this lesson we're going to look at solving multi-step equations. I've tried to cover quite a lot of different examples and be quite comprehensive in that. If you think there are particular examples that you need to do, then I've put chapters in the description of this video and you can go and skip ahead to that. Let's get into our first example. Solve 3x add 7 is equal to 5x subtract 3. What we want to do is we want to collect all of our x terms onto one side of our equation. There are more x terms on this side, so I want to collect them all over to the right hand side. In order to do that, I'm going to get rid of them on the left hand side. I will subtract 3x from both sides. That leaves me with 7 on the left hand side, and I'll do my 5x subtract 3x to give me 2x, and I can't forget that I need to write the subtract 3. From here, I'm going to collect all of my number terms onto the left hand side. So I want to undo this subtracting 3. To do that, I'm going to add 3. I've done that to both sides. 7 add 3 is 10, and I'm left with 2x on the right hand side. Last step is to divide both sides by 2, and that's going to leave me with 5 is equal to x, or x is equal to 5. That is the same thing. Pause the video and give this one a go. Okay, let's run through it. We'll subtract 6x from both sides to try and collect my x terms to one side. That's going to give me 3x subtract 5 is equal to -8. Notice that I'm only really doing one thing at a time here. You could do two things if you want, but just to keep it simple, I'm just doing one thing at a time. I'll add 5 to both sides now to get rid of the subtract 5 on the left hand side. That leaves me with 3x on the left, and it leaves me with -3 on the right hand side. I'll then divide both sides by 3. On the left, that gives me x. On the right, that gives me -1. All right, next example, 11 subtract 3x is equal to 1 add 2x. And the general gist behind these is you want to collect all of your x terms onto one side and all of your number terms onto the other side. I could subtract 2x from both sides, and that would bring all of my x terms onto the left-hand side. But to avoid a negative coefficient of x, I'm actually going to add 3x to both sides like this. That leaves me with 11 on the left is equal to 1 add 5x on the right-hand side. I then subtract 1 from both sides. That gives me 10 is equal to 5x. And then I divide through by 5. And that gives me 2 is equal to x, or x is equal to 2, same thing. Pause the video and give this one a go. Let's go through this one. I'm going to add 4x to both sides to get rid of the -4x on the left-hand side. That's going to leave me with 1 on the left is equal to 15 add 7x on the right-hand side. Now subtract 15 from both sides to make sure that your x's are on one side and your numbers are on the other. 1 subtract 15 is -14, and that's equal to 7x. Then divide by 7 on both sides. -14 divided by 7 is -2, and that gives me x on the right-hand side. My answer is x is equal to -2. Next example, 2x add 4 divided by 4 is equal to 5. I want to undo the division by 4 first because 2x and 4 are both being divided by 4 here. So let's multiply both sides by 4. That's going to leave me with 2x add 4 on my left-hand side and 20 on my right-hand side. Then subtract 4 from both sides, giving me 2x is equal to 16, and then divide both sides by 2, giving me x is equal to 8. Try this one and see how you get on. So you should have multiplied both sides by 2. That would undo the division by 2 on the left. That leaves you with 3x subtract 1 is equal to 20. Then you want to add 1 to both sides to undo the subtracting 1. That's going to give you 3x is equal to 21. Then divide both sides by 3. X is equal to 7. So this one's similar to the last one, but we've got one little extra bit involved. So I am dividing by 3. I'm also subtracting by 4. And I want to undo this subtracting by 4 first. In previous lessons, we've talked about this idea that when we're solving equations, we want to undo in the reverse order that we would normally do when we're calculating. So this is our order of operations pyramid. We got brackets, powers and roots, division, multiplication, addition, and subtraction. And I want to work my way back up through this when I'm solving equations. I'm going to undo the subtraction first. And to do that, I'll add 4 to both sides. That leaves me with x add 4 divided by 3 on the left-hand side is equal to 9. Now, although I just said that we undo our addition and subtraction before our division, and we do have both on the left-hand side of this equation, because I'm dividing both the x and the positive 4 by 3, I actually want to undo the division by 3 first. in a sense, we could think of the left-hand side as x add 4 divided by 3. And so we want to undo our division before we deal with what's inside the bracket. So I'll multiply both sides by 3. That leaves me with x add 4 on the left-hand side is equal to 27 on the right-hand side. Then I can subtract the 4 from both. That leaves me with x is equal to 23. All right, now try this one. I'll start off by subtracting 7 from both sides. On the left, that'll leave me with x subtract 1 over 2. And on the right-hand side, if I do 5 take away 7, that will take me to negative 2. I'll then multiply both sides by 2, and that leaves me with x subtract 1 is equal to negative 4. I can then add 1 to both sides, and that leaves me with x is equal to negative 3. If you're enjoying the video so far, please drop the video a like and subscribe to the channel. It really does help us out, so thank you for that. Okay, our next example involves some brackets, and in previous lessons we've seen how we are able to divide both sides by 3, and that would leave us with x subtract 3 is equal to 14 over 3. But since 14 is not divisible by 3 to leave us with the whole number, we're actually not going to use this method in this example. Instead, what I can do is I can do what's called expanding my bracket. That means I'm going to multiply 3 by x and multiply 3 by negative 3. 3 multiplied by x is 3x, 3 multiplied by negative 3 is negative 9, and that's equal to 14. Then I can solve it like a normal two-step equation. I'll add 9 to both sides. That leaves me with 3x is equal to 23, and then I'll divide both sides by 3 like this. On the left, that gives me x, and on the right, that gives me 23 over 3. Now 23 is not divisible by 3 to give us a whole number, so I'm actually just going to leave my fraction like this, and that's absolutely fine. Pause the video and give this one a go. Okay, let's run through it. So we're not going to divide both sides by 5. Instead, we're going to multiply our bracket out. 5 multiplied by x is 5x. 5 multiplied by 2 is 10, and that's equal to 13. Subtract 10 from both sides, leaves you with 5x is equal to 3, and then divide both sides by 5. I should write that in. And that gives you 3 over 5. And it's fine to leave your answer like that, so that's okay. All right, so similar question to the last one. We've got brackets on the left-hand side and the right-hand side. This time I'm going to expand the bracket on the left-hand side of the equation. So do 3 multiplied by x and 3 multiplied by negative 5. Just be careful because of the symbol in front of the 5. It does tell me it's a negative 5. 3 multiplied by x is 3x. 3 multiplied by negative 5 is negative 15. And I'll expand the bracket on the right-hand side. I'll do 2 multiplied by x. And I'll do 2 multiplied by 1. Then I'm going to collect my x terms to one side. I'm going to collect it to the left-hand side because that's where there are more of them. I'll subtract 2x from both sides. That leaves me with x subtract 15 is equal to 2. And then I'll add 15 to both sides to get rid of the subtracting 15. That leaves me with x is equal to 17. And that's my answer. Pause the video and give this one a go. Okay, so this time you actually could have divided by 2 on both sides. If I divide the left-hand side by 2, well, that goes to 1. And if I divide this side by 2, that goes to 2. I could then leave this bracket as x add 3, because multiplying both of those by 1 doesn't change anything. And then I'd have 2 lots of x, subtract 4 on the right-hand side. I could then subtract x from both sides, and that would leave me with 3 is equal to x subtract 4, then add 4 to both sides, giving me an answer of x is equal to 7. You might have done it slightly differently. You might have expanded your bracket on the left to give you 2x add 6 and set that equal to 4x subtract 8, and then taken away 2x from both sides to give you 6 is equal to 2x subtract 8, and then added 8 to both sides to give you 14 is equal to 2x, and then divided by 2 to give you that answer that we've seen before where x is equal to 7. So either way you did it, that's absolutely fine. So another example with brackets. Here we have 5 upon x add 2, subtract 4 upon x subtract 3, and that's equal to 10. Now I'm going to expand my brackets in the same way as I did before. So I'll do 5 multiplied by x, and I'll do 5 multiplied by positive 2 to give me 10. And then I have to be careful here. People often forget that this is actually a negative 4. So I'll do negative 4 multiplied by x to give me negative 4x. And here's the bit where everyone forgets to do it. They often do 4 multiplied by negative 3, but we want to treat this as a negative 4. So I'll do negative 4 multiplied by negative 3 to give me a positive 12. So just be careful with that. That's where people often slip up. And that's equal to 10. I'm going to collect together my like terms on the left-hand side. So x's with x's, numbers with numbers. So 5x and negative 4x I'll collect together. That's going to give me x. And then I'll collect my positive 10 and my positive 12 together to give me positive 22. And that's equal to 10. I can then subtract 22 from both sides, and that's going to leave me with x is equal to negative 12. Try this one and see how you get on. Okay, let's expand our first bracket. 4 multiplied by x is 4x. 4 multiplied by negative 1 is negative 4. And then remember that is a negative 2 multiplied by x to give you negative 2x. And negative 2 multiplied by negative 1, really careful with that, that's positive 2. That's equal to 22. Then I can collect together my like terms, so I'll collect 4x and negative 2x together to give me 2x. And I'll collect negative 4 and 2 together. Just be careful to consider that as negative 4. Some people don't circle the symbol in front of the number, but you need to do that. Negative 4 add 2 is negative 2. That's equal to 22. Then add 2 to both sides of your equation, leaving you with 2x is equal to 24. And then divide both sides by 2, giving you an answer of x is equal to 12. One more example with some brackets. Here we have 6, subtract 2 upon x subtract 3, and that's equal to 10. I'm going to start off by expanding my bracket. So there are different ways I could think of this. I'm going to think of it as negative 2 multiplied by x and negative 2 multiplied by negative 3. I've got 6. I'll do negative 2 multiplied by x to give me negative 2x. And I'll do negative 2 multiplied by negative 3 to give me positive 6. And that's equal to 10. So I'll show you a different way to do the question in a second, but let's crack on with this. Let's tidy up my two numbers on the left-hand side. So I have negative 2x and I have 6 and 6, which is 12, and that's equal to 10. Then subtract 12 from both sides, leaving you with negative 2x is equal to negative 2, and then divide both sides by negative 2. On the left-hand side, that leaves you with x, and then on the right-hand side, negative 2 divided by negative 2 is positive 1, so x is 1. Now the other way you can do the question is you can think of it as I'm doing 6 take away 2 lots of this bracket. So as long as I'm careful to remember that I'm taking away 2 times this bracket, then I can do it this way. So 2 times x is 2x, and 2 times negative 3 is negative 6, and that's equal to 10. I've still accounted for the negative in front of the bracket. Like this, in theory, that would be a negative 1 in front of the bracket. I can then do negative 1 multiplied by 2x to give me negative 2x, and negative 1 multiplied by negative 6 to give me positive 6. And that's equal to 10. And then I would solve it in the same way like I did before, and it gives me the same answer. So I'd still end up with x is 1. Give this question a go, and we'll run through it in a second. Okay, so what I have in front of my bracket is a negative 1. So I could think of this as negative 1 multiplied by x and negative 1 multiplied by 2. Or I could think of it as I need to subtract x and I need to subtract 2. So let's think of it in terms of negative 1 multiplied by x. Well, that would give me negative x, and then negative 1 multiplied by 2 gives me negative 2, and that's equal to negative 4. Collect together your numbers on the left-hand side. I have 5 and negative 2. So I'll do 5 subtract 2 to give me 3. Subtract x is equal to negative 4. Then what I can do is I can subtract 3 from both sides. That leaves me with negative x is equal to negative 7. And then multiply both sides by negative 1. That will get rid of the negative 1 on the left-hand side. Negative x multiplied by negative 1 is positive x. And negative 7 multiplied by negative 1 is 7. Our next examples involve some powers and roots. So here we have 2x squared add 2 is equal to 20. I'm doing 3 different things here. I'm adding 2, I'm multiplying by 2, and I'm squaring. And if you remember, when we're solving equations, we want to undo addition and subtraction first. So I'll subtract 2 from both sides. Then I want to undo my multiplication and division. And then lastly, I undo my powers. Let's go ahead with this. If I subtract 2 from both sides, that is the opposite of doing the add 2. So on the left-hand side, I'm just left with 2x squared. And on the right-hand side, I'm left with 18. I then want to undo the multiplication. So I'm multiplying x squared by 2. To undo that, I'm going to divide both sides by 2. That leaves me with x squared is equal to 9. And then I want to undo my squaring, so I'll square root both sides. And I need to remember that I get 2 answers when I take the square root of a number. So my answer here is going to be x is equal to plus or minus. I use those symbols to show that I'm going to get 2 answers, the square root of 9. So the square root of 9, think what number multiplied by itself gives me 9. Well, the answer to that is 3. So my answer is positive or negative 3. Let me just write that out. So x is equal to 3, that's the positive 3, and x is equal to negative 3. And the reason for that is, if we come back up to this line, we have x squared, that's a number multiplied by itself, and that's equal to 9. Well, what number multiplied by itself gives you 9? Well, the obvious answer is 3. 3 times 3 is 9. But also we have that second answer, negative 3 multiplied by negative 3 is also positive 9. So that's why we have these two answers down here. Give this one a go and then we'll run through your answer. Okay, so you want to start off by adding 7 to both sides. On the left-hand side, that would leave me with 5x squared. And on my right-hand side, that would leave me with 45. I then want to divide by 5 on both sides. On the left-hand side, that leaves me with x squared. On the right-hand side, that leaves me with 9. So same position as the last time, we're going to square root both sides. On the left-hand side, that would undo the squaring to leave me with x. And then I want to say that it's plus or minus the square root of 9. These symbols show that I'm going to have two answers. So x is equal to positive and negative 3. So we're looking at lots of different ways this can be asked. Here's our next way. X subtract 2 all squared is equal to 9. Now if I consider my order of operations, I do have addition and subtraction, but they're inside the bracket. So that means I actually want to do those last. What I want to undo is I want to undo the squaring first, because I see that that actually comes before anything inside the bracket. So what I want to do is I want to square root both sides. And if we quickly have a think, well, what could be inside this bracket that would multiply by itself to give me 9? Well, we've already seen that in the previous example. The bracket could be 3 times 3 to give me 9. Or the bracket could be equal to negative 3 multiplied by negative 3, and that would give me 9. But I know inside that bracket needs to either be 3 or negative 3, and I just want to bear that in mind when I do this. If I square root the left-hand side, that leaves me with x subtract 2. And if I square root the right-hand side, well, remember we said that's plus or minus the square root of 9. And so I actually have two options here, and I'm going to write them both out. And the reason I have two options is because, like we said, we could have positive or negative 3. So in a sense, we've got two equations we want to solve. On the left, I'll look at x subtract 2 when it's equal to 3. And on the right, I'll look at x subtract 2 when it's equal to negative 3. We're going to have two different solutions here. If we add 2 to both sides like this, that leaves me with x is equal to 5. And if I add 2 on both sides here, that's going to leave me with x is equal to, well, negative 3 add 2 is negative 1. Here's my two answers, and let's just see how that works. If we take our original equation, which is x subtract 2 all squared, and that's equal to 9. If I put in a value of 5 inside my bracket in place of x, well, that leaves me with 5 subtract 2 squared, and that should be equal to 9. Well, 5 subtract 2 is 3, and I know that 3 squared is 9, so that works. Let's also look at our second solution. Well, our original equation is x subtract 2 all squared is equal to 9. And we've said that x is negative 1 is an answer as well. So if I place negative 1 in place of my x, if I substitute, I get this. Inside my bracket, I need to do negative 1 take away 2. Well, that gives me negative 3, and that's squared. And the brackets run to negative tell me that I need to do negative 3 multiplied by negative 3, which is 9. And that solution also works. So hopefully you can see x equals 5 and x equals negative 1 are both valid answers to that equation. Give this one a go and remember that you should have two answers. Okay, we're going to start off by undoing the squaring, so we'll square root both sides. On the left-hand side, that'll leave me with x add 5. And on the right-hand side, I'm going to have the positive and negative result of the root of 25. Root 25 is 5, so I'll have x add 5 is equal to, we said the root of 25 is 5, so I'll have positive and negative 5 as my answers. I need to consider both of those answers, so let's look at x add 5 when that's equal to positive 5, and we'll look at x add 5 when it's equal to negative 5 as well. Just solve this one-step equation, subtract 5 from both sides, and on the left-hand side that'll leave me with x, on the right-hand side that'll leave me with 0. And similarly, I'll solve the equation on the right, I'll subtract 5 from both sides. On the left-hand side that leaves me with x, and negative 5 subtract 5 is negative 10. So those are my two answers. And let's put them inside our bracket just to show how that works. So I could have 0 add 5 squared, and that should be equal to 25. Well, of course, that bracket is just 5 squared, which is 25, and that's equal to 25, so that works. And my other option is x is equal to negative 10, so let's substitute that in instead. I've got negative 10 add 5, and that's squared, and that should be equal to 25. Negative 10 add 5 is negative 5, and I need to square that. And negative 5 squared is 25. So you can see that negative 10 works as a solution, and so does 0. We're going to look at a trickier example involving some brackets here. So on the left, we have x subtract 3 all squared, and that's equal to 34 subtract 6x. So we actually don't want to square root both sides because we're going to run into trouble if we square root our right-hand side. So we need a different way to do this. And instead, what we're going to do is we're actually going to expand the left-hand side of this equation. Now just be careful because oftentimes people take x subtract 3 all squared, and they square the x term, and they square the negative 3 to give them 9, and they think that's their answer. But that's not actually the case. X subtract 3 all squared means x subtract 3 upon x subtract 3. That's what my left-hand side is, and I'm just going to rewrite my right-hand side. I then need to expand this bracket. So if you've watched previous lessons with me, we know that we do x multiplied by that entire bracket, and we do negative 3 multiplied by that entire bracket. How would I write x multiplied by that entire bracket? Well, I'd write it like this: x multiplied by x subtract 3. And then I need to do negative 3 multiplied by the entire bracket as well. So I like writing it this way just so that we don't forget what we're doing. And I'm going to rewrite my right-hand side just so that I know that they're equal. I can then expand each of these brackets in turn. So I'll do x multiplied by x to give me x squared. I'll do x multiplied by negative 3 to give me negative 3x. I'll do negative 3 multiplied by x to give me negative 3x. And I'll do negative 3 multiplied by negative 3 to give me positive 9. And that's equal to 34 subtract 6x. I'm going to collect together my x terms on the left-hand side. That gives me x squared subtract 6x, add 9. And on my right-hand side, I have 34 subtract 6x. Then what I've noticed is if I add 6x to both sides, it's going to remove the 6x from both sides. Negative 6x add 6x is 0. On the left-hand side, it just leaves me with x squared add 9. And over here, same idea, negative 6x add 6x is also 0, so I'm left with 34 on the right-hand side. I can then subtract 9 from both sides, giving me x squared is equal to 25. And then I want to square root both sides of my equation. That gives me x is equal to the square root of 25, and I have to remember I've got my positive and negative answers. And I've run out of room, so I'll come over here. X is equal to positive and negative 5. That's my answer. Pause the video and give this one a go. All right, so what you want to start off by doing is writing out x add 8 all squared as x add 8 upon x add 8. And then what we want to do from there is we want to expand the left-hand side. So we want to do x multiplied by the entire bracket and 8 multiplied by the entire bracket. That way we make sure we're multiplying all of our terms together, not missing anything. So x multiplied by this bracket, I would write like this. So x upon x add 8. And then I'll do positive 8 multiplied by the entire bracket as well, like this. I'll just rewrite my right-hand side. That gives me this. I can then expand each of these brackets in turn. So x multiplied by x and x multiplied by 8. That gives me x squared add 8x. And then same idea with the second bracket. I'll do positive 8 multiplied by x to give me 8x. And I'll do 8 multiplied by 8 to give me 64. That's equal to 16x add 65. Let's collect together our x terms on the left-hand side. So I have x squared add 16x add 64. And that's equal to 16x add 65. I'll then subtract 16x from both sides, which will get rid of the 16x on both sides. That leaves me with x squared add 64 on the left is equal to 65 on the right. Then subtract 64 from both sides. That gives me x squared is equal to 1. Then I square root both sides. X is equal to plus or minus the square root of 1. And the square root of 1 is just 1. So my answer is x is equal to positive and negative 1. Okay, we've seen a lot of examples in this lesson. Here's our last set of examples. Let's give them a go. So it says solve x add 3 divided by 3 is equal to 2x add 9 over 7. Now the way I could start this is I could try and undo this division by 3 on the left-hand side by multiplying both sides by 3. On the left-hand side, that would leave me with x add 3. And on the right-hand side, it would leave me with 3 lots of 2x add 9 all over 7. I could then undo my division by 7 on the right by multiplying both sides by 7. That would leave me with 7 lots of x add 3 on the left-hand side, and 3 lots of 2x add 9 on the right-hand side. So you could do it like that, but a quicker way is to multiply the denominator of this fraction with the numerator of the other fraction, and multiply the denominator of the right fraction by the numerator of the left fraction, like this. So I'd do 3 multiplied by 2x add 9, and that would give me that. And I'd do 7 multiplied by x add 3, which would give me this. This is a quicker way of getting to the same place I was at doing it the previous way. I'll then expand out my brackets, so I'll do 3 multiplied by 2x to give me 6x, and I'll do 3 multiplied by 9 to give me positive 27, and then I'll do 7 multiplied by x to give me 7x, and 7 multiplied by 3 to give me 21. I then want to collect all of my x terms to one side and all of my numbers to the other. I think I'm going to get all my x terms on the right hand side because there are more of them over here. I'll subtract 6x from both sides. That leaves me with 27 on the left hand side, and it leaves me with, well, 7x subtract 6x is just x, and I've still got my 21. I'll then take away 21 from both sides. 27 subtract 21 is 6, and I'm left with x on my right hand side. My answer is x equals 6. Pause the video and give this one a go, and then we'll run through it. So you should have multiplied the denominator of this fraction with the numerator of the other fraction, and the denominator of the fraction on the right with the numerator of the fraction on the left. So you got 7 multiplied by x add 1, and that's going to be equal to 5 multiplied by 2x subtract 1. I'll then expand my brackets on both sides, so 7 multiplied by x is 7x, 7 multiplied by 1 is positive 7, and then I'll do 5 multiplied by 2x to give me 10x, and 5 multiplied by negative 1 to give me negative 5. I'll then subtract 7x from both sides, leaving me with 7 is equal to 3x subtract 5. I can then solve this two-step equation, add 5 to both sides. That gives me 12 on the left, 3x on the right. Divide by 3 on both sides. 12 divided by 3 is 4. 3x divided by 3 is x. My answer is x equals 4. If you're using our lesson booklets, you can now complete all of your exercises. That's 1 to 4. Thank you for watching this video.